I would like to introduce the concept of rationalizing denominators using conjugates. Before beginning, I would like to warm up with a few ideas. Consider difference of squares. If I have x minus 3, I need that counterpart, which is x plus 3, so that when I FOIL this, first with first, I get my x squared. Outer, I have 3x. Inner, I have minus 3x. So I don't get a middle term that it drops out. You have your 3x, your minus 3x. Those are evil opposites. So they drop out. And then the L for FOIL, last with last, I have negative 3 times 3, which is negative 9. So I've got the structure of a difference of squares. Now I want to do several of these just to make sure we're warmed up and we understand this concept before introducing the rationalizing denominator part using this strange thing called a conjugate. So for a second idea, let's say I have 2 tiger minus 5. I need that balanced with a 2 tiger plus 5. If you recall, in a difference of squares you have the same two terms, two sets of parentheses with two different signs. And when it multiplies out, you only get two terms. So you have the difference of two squares. In this scenario, first with first gives me 4t squared. Outer's 10 tiger. Inner's minus 10 tiger. So that cancels out. And then the last is minus 25. Let's do one more of these. Let's say that we had 3w plus 7. What would I need for this other parenthesis to make a difference of squares? Hopefully you're thinking 3w minus 7. Now when I FOIL this, first with first gives me 9w squared. Outer's negative 21w. Inner's 21w. And those will cancel out. Once you start to recognize the structure here, I don't even really need to do this multiplication for the outer, inner, because I know they're always going to cancel out. And so then I just go to my last. 7 times negative 7 is negative 49. So let's introduce a conjugate. A conjugate, by definition, is the missing part. It's the missing part for a difference of squares. And I'll start with our first example, why we need a conjugate and how it's going to be used for rationalizing denominators. Recall that we were working problems that were like 3 over square root 2. To solve this unstable fraction, or to simplify it rather, we multiply the top and the bottom by a rad 2. That allows us to promote the radical, and we get a 3 rad 2. Rad 2 times rad 2 is a regular 2. This fixed our scenario to make sure we have a stable fraction, that we had a rational value in our denominator. Enter our example here. We'll call this example 1. If I have 2 over 3 minus square root 5, I cannot simply multiply by rad 5 on the top and bottom, because if I do that, I will get 2 rad 5 upstairs, but I'd have to distribute the rad 5 to both parts here, and yes, it would get rid of this radical 5 here, it would become a regular 5, but then this becomes 3 rad 5. And so it becomes a vicious circle where I would just alternate my radical 5 from the first part of the denominator to the second part and back and forth as I continuously try to multiply just by rad 5. So in order to fix that, what we do, we multiply by the conjugate. So as you look at this denominator, hopefully you're recognizing and seeing why I reviewed the difference of squares at the top here. If I multiply by 3 plus radical 5, this will allow me to get rid of that radical in its totality from the denominator. And so I'll start with the denominator. And so I'm going to just come down here. 3 times 3 is 9. Outer, outer, inner, inner. Don't really care because I know with the structure of a difference of squares, this has to cancel out. And so I can go immediately to the last with last. Negative rad 5 times positive rad 5 would be a negative. And rad 5 times rad 5 is 5. And I go back to the idea of a difference of squares. I am expecting to have this minus sign here. See how a difference of squares, that's why we call it a difference, a subtraction of two square values. And that's what I get here. The 9 is the square of 3, and rad 5 squared is 5, which actually is a square to that radical. Now, before I go any further, I like to simplify my denominators. 9 minus 5 is 4. The reason why I like to do that, you're always going to look for your opportunity to cancel. And what I mean by that is it's going to be easier for me to cancel now rather than distributing and canceling later. So I see that the 2 and the 4 can be reduced. I will reduce that. And so I'll go 2, 4, 2 becomes 1, 4 becomes 2. That means that I would distribute the 1 across this, so I'd have 3 plus rad 5, which would be 3 plus rad 5. And then just to clean this up, it tells me that my final answer would be 3 plus radical 5 over 2. Now before I move to the next example, there's so many different things I could explain off of this. I want to fix this up here a little bit. I'm going to redo this example. I had the 2 over 3 minus rad 5. And we said that we would multiply top and bottom by 3 plus rad 5. I had to supply the conjugate. When you have two terms, you're going to supply the conjugate like that. Now, let's pretend for a second that I didn't see that opportunity to cancel. So I'm still going to do the same math I did a moment ago. 3 and 3 was 9, minus rad 5 and rad 5 is 5, so that gives me 4. Let's say I didn't see that opportunity to cancel the 2 with this 4, the 2 on the top and the 4 on the bottom. So I went ahead and I distributed. So 2 times 3 was 6, and 2 times rad 5 would be 2 rad 5. This gives me 6 plus 2 rad 5. When you have a fraction like this, you have to cancel with the concept of all or none, meaning that if you're going to cancel something, it has to come from each and every part or no parts. And so we'll bring us the answer we had here just a moment ago, where I had the 3 plus rad 5 over 2. Notice that I can take a 2 out of each and every part here, but it has to be out of each and every part. I divide by 2, I get 3. I divide by 2, I get 1. I divide by 2, I get 2, which means that this is equivalent to 3 plus 1 rad 5, or just rad 5 if you prefer, over 2. And you see, that's the same answer that I got earlier, but here I had to employ that technique where I canceled each and every piece. So there's, every time you have a plus or a minus or a standalone like this, you have to cancel from it. You can't just pick and choose. And like I said, I want to kind of further this before I go into any more examples. So I'm going to go to a second idea. Say I had 7 plus 5 rad 3 over 14. Some of you are going to feel like you need or you have to cancel here the 7 and 14. You're not allowed to. It has to be all or none. And so another example, if I said I had 5 minus 15 rad 2 over 20, when I see this situation, I recognize that I can take a 5 from each and every part. I am expected to do that. I have to do that. So I cancel, or I take a 5 out, that becomes 1. Take a 5 out, that becomes 3. Take a 5 out, that becomes 4. And so then I could write this as 1 minus 3 rad 2 all over 4. This is the canceling through all or none. It's all parts or no parts. And it's an important idea to stress before we do a bunch of these examples. And so that's going to be our introduction with example 1 for rationalizing denominators using conjugates.